Hello, this is the lesson over chapter 9, lesson 1. So in this lesson, we are talking about quadratic formulas and their graphs. And so I've already written down all this stuff, so you don't have to sit here watching me write it. But I'm going to read through this and explain. There's a lot of information, a lot of new information explaining what a quadratic formulas graph looks like. And then we're going to actually break it down and talk about how to draw this graph and what characteristics do we need to look for in the formula. So a quadratic function is written in the form of a or y equals ax squared plus bx plus c. And so we've spent chapter 8 and some of chapter 7 factoring out a quadratic formula. We didn't call it a quadratic formula, we just factored, but we saw this type of equation. And there's actually a graph that goes with this type of equation. In this equation, a does not equal 0 because we know that if 0 was in place of a, then there would be no first term, right? 0 times x would just be 0. And this form is called the standard form of a quadratic equation. The degree of the polynomial in a quadratic function is 2. And we talked about that in chapter 7, where you can look at the degree of an equation. And we know this is called a quadratic because there is a degree of 2. So the simplest quadratic function is actually just y equals x squared, because as long as it's to a degree of 2, it counts as being a quadratic, right? Or the parent function of the quadratic would be f of x equals x squared. And so when we see the f of x, it just means it's a function, right? We're going to, instead of calling it an equation, we call it a function. The graph of a quadratic function is a U-shaped called a parabola. And it actually looks like this. I don't know if you've heard the word parabola, but it looks like this. Or going the opposite way, okay? So it's a U-shaped, either pointing up or pointing down, called a parabola. A parabola is symmetrical, meaning it's the same on both sides. So if I were to draw a line here and then fold it in half, it would be completely identical on both sides. Meaning you can fold it so the two sides match exactly. The fold or the line that divides the parabola into two matching halves is called the axis of symmetry. So this is what we call the axis of symmetry. We can call it AOS for short. The highest or lowest point of a parabola is its vertex. I don't know if you've heard that word before, but the vertex is the lowest point or the highest point, okay? Which is always going to be on the axis of symmetry because the tippy top or the very bottom will be kind of on the crease, on the fold for that parabola. If a is greater than 0 in this equation, in this quadratic equation, the parabola opens upward. So basically this is saying if you have a positive, right, a positive a, then it's going to open upward. And the vertex is the minimum or the lowest point. So it's going to look like this. Opening upward, the vertex is on the bottom. If a is less than 0, so this being a negative, then the parabola opens downward. It's going to point down. And the vertex is going to be the maximum or the highest point. To find the axis of symmetry and the vertex, use negative b divided by 2a. So we look back at the equation and we find that middle term, negative b, and 2 divided by 2a. To quickly graph parabola, find the coordinates of the vertex, then find several points on one side of the vertex, and finally reflect those points across the axis of symmetry. For graphs of functions of the form y equals ax squared, the vertex is the origin. So when there's no plus bx plus c, then the vertex is just on 0, 0. The axis of symmetry is the y-axis or x equals 0. So let's take a look at this. We're going to identify the vertex and some of these other characteristics of this parabola. And so the big question here is, what is the vertex? So we're just going to identify it. The vertex is right here. It is at -2, -3. So we're just naming the location, -2, -3. And it is it a minimum or a maximum? If the vertex is on the lowest point, this is called a minimum. Okay, what is the axis of symmetry? So the axis of symmetry will be where the vertex is. It is at x equals -2. And we have to specify it's x equals -2 because it's intersecting on the x-axis at -2. Where's the y-intercept? So where is it crossing over on the y? It's crossing over right here, which is at 0, 1. So the y-intercept is at 0, 1. Okay, so we're just identifying some of these characteristics. Let's take a look at our next part. Now we're actually going to graph it. So we have a real equation. We need to graph this parabola. And the basic thing that we could do is just create a table and create some points. So we have our y, we have our x, and then we have our actual equation. Y equals 3x squared plus 6x minus 4. Now bear with me, I might have to make this a little smaller. So I'm just going to pick a few points. Maybe I'll have a -2, -1, and a 1 as my y. So I'm going to insert my y into, oh, actually, no, I'm not doing this. This actually should be switched around. So it should be, you can change it on yours, not y first. We usually put the x as the input, right? So x is the input, y is the output. So I switched those around. So we're going to input x of -2, meaning 3 times -2 squared plus 6 times -2 minus 4. So you might need some more space to kind of work this out, but -2 squared is 4. 4 times 3 is 12. 12 plus, this would be -12. 6 times -2 is -12. So 12 minus 12 minus 4 would make my y -4. Then I have 3 times -1 squared plus 6 times -1 minus 4. So 3 times -1 squared would just be 3 plus -6 minus 4. And so bring this all together, that's -7. And then 1, +1 would be 3 plus 6 minus 4, which would be 5. Okay, so these are my points now. And you could plot them on there if you wanted to. -2, -4, right here. -1, -7. That's like way down here, off my graph a little bit. And then +1, 5. +1, 5. So you can kind of see potentially you've got a graph that's like curving down and going up like this, but it's not super clear. So to find, one thing that we really do need to find is the axis of symmetry. And if we look back at our notes on the front side, axis of symmetry, to find that is -b divided by 2a. So in this equation, b is 6. You write this as -6 divided by 2 times 3. A is 3. Okay, so divide this, and that's -6 divided by 6, which is -1. So my axis of symmetry, I'll use a different color here, is at -1. So I'm going to draw a little line right here to show this is kind of where my graph is folding. And you know what? As I'm drawing this, I realized I actually have found the vertex. I just didn't know it. I had found the vertex. So now that you have the vertex, you know that your graph it's just folding directly in half, meaning I can mirror this point to the other side of my axis of symmetry and draw my point across. Over here, it's 2 over. So I'm going to bring it 2 over to the left. And I'm mirroring this. And then I'm going to connect my dots. And it's harder for me to graph this on a pad here for the computer. But then if I connect my dots, you just roughly kind of draw a curve where this is what we call the minimum, right? Because it's pointing down. And it's this graph is pointing up. And then it says, what are the domain and range? So if we want to list out the domain and range, if you remember from pre-algebra, I really had you guys drill in your head. Domain is the X, right? And then the range is the Y. So domain, the X values, because this technically goes up forever and ever and ever, and it's not going up vertically, it's actually curving outward towards, the left here. This is curving outward towards the left. And so eventually it will hit every number if we have an infinite amount of space to draw a graph. So the domain for X is that it's going to continue to move out this way. It's going to continue to move out this way. And so the domain is really all real numbers. So really this is saying all real numbers, anything on your graph will be counted as a domain, can be a potential domain for this graph. Now the range though, the vertex is at a minimum of -7. This is at -1, -7. So your graph will not include any points that is below -7. So the range is y has to be greater than or equal to -7 because it includes everything above -7, right? Everything above here is potentially on your graph, right? If you draw it forever and ever. However, it will not go below -7. So the range is that y is greater than -7. All right, let's do one more. Let's try to do this without having to graph every single point. So I'm going to teach you a few characteristics of first how to find the vertex, how to find the axis of symmetry, the y-intercept, and then using those three qualities to graph. So I would take some good notes over this because these three parts, if you know how to use these three parts, you don't have to make a table like we did above and just blindly put in random points to graph it anymore. So to find the vertex is actually the same way as looking for the axis of symmetry. So I'm going to put this together as one kind of formula. And remember, it's -b over 2 times a. So in this case, it is -6 times 2 times -3 because a is -3. Then I'm going to work this out. -6 divided by -6 is +1. So my axis of symmetry, I would draw it right away, is at -1. And then to find the vertex, you would use that one that you just found. And that is where it's on the X value, right? So to find it, you would replace your X value with +1. And that will help you find the Y. So you're using this input and output idea to find the Y coordinate if your X coordinate is at +1. This will be -3 plus 6 minus 5. Y equals -2. So the vertex is at +1, -2. I'm going to plot that point down, +1, -2. That's right here. Then the y-intercept. You know that the y-intercept, well, you can either find it by replacing the y with 0 and working it out, but what we've learned, you probably don't know this, but this is just a fact. The y-intercept is always C. So look at where C is. It's -5, meaning the y-intercept is at -5 on your graph, on the y-axis. Now that we have the vertex and another point, all we have to do is mirror this other point across the axis of symmetry, and then connect our points and make a little upside down U shape. And that's it. That is your graph. We'll definitely talk more about this, but these are the basics for graphing a quadratic equation.